Support vector machines are a set of machine learning models designed for numerous applications, but they're mostly used for classification to separate data into different or distinct classes. At their core, support vector machines, or SVMs, work by finding the optimal decision boundary, known as the hyperplane, that maximizes the margin between different classes. The margin is the space between the hyperplane and the closest data points, and SVMs prioritize maximizing this margin for robust and reliable classification. But what really sets SVMs apart from other classification models is the use of kernel functions to transform the input data into a higher dimensional space so that a linear separation becomes possible. SVMs are robust to outliers as they focus on the support vector near the decision boundary rather than every data point, and they can handle high-dimensional data effectively, making them suitable for complex dataset with multiple features. The power of support vector machines extend across various domains and can be used for image classification, spam filtering, text analysis, and many other more applications.